Hallo allemaal. Hello everybody. I'm Sam Vanhoutte, coming from Belgium, as you just learned. I'll talk about Azure Event Grid today. And while I was prepping this session, I also looked at the agenda. And what I saw is that I will cover and touch a lot of services that the other speakers will talk about for the rest of the conference. So that's nice. I'll refer quite a lot to their sessions that are coming up. So I come from Belgium, and I'm CTO at Codit. So we are based in 7 countries in Europe, and we focus on Microsoft Azure solutions for customers. We have 180 people. Now, enough about us. What I'll talk about is Azure Event Grid. I don't know how many people have used Azure Event Grid in this room. 15-ish. I hope after today that you get more enthusiastic about that service because it's really powerful. And it really fits into the whole messaging and service communication area of Microsoft Azure. So to understand where it fits and when you should use it, I think it's important to have a good clarification on the different types of events you can get. So the first thing you quite often see in applications is intents. Like, I want to create a sales order. I want to schedule a job to do something. That is myself as an application or as a person declaring that I expect something to happen, right? The other side, quite often you have facts. Think about telemetry streams and IoT and so on. These are just facts. The light is on. Temperature is 25 degrees. These are log files that get filled at web applications, right? So that's a big difference. And you could say that on the left side, you have the messages. On the right side, you have events. So Event Grid will be typically more used for the right side type of events, while you have other services that will be used on the left side for messaging. You have different types of events. You have discrete events, and you have series of events. So series of events, it's quite common to think about time series of signals, of vibrations of engines and things like that, things that just come as a stream, log files, clicks on a website, these things. The other type, you have discrete events. That's something that happens at random, like a state that changed, an order that got fired, things like that. So these types of events is something that you can handle with Event Grid, especially the ones on the left. These are quite suited for that. So this is the entire messaging landscape. The good thing is that I think Eldert has a session later today that covers all these services and really talks about when to pick which. I think the 3 most common ones for these type of applications are Service Bus and Azure Queues, although I typically always want to use Service Bus queues, Event Hubs, and Event Grid. So regarding them, I think Service Bus is typically for your enterprise messaging, for messages that you really want to have delivered that are crucial to get. Think about financial data and so on. Event Hubs is more for the streams. So think about your log files, think about the telemetry and so on for your big data pipelines if you want. And then Event Grid is more if you want to do reactive programming, and that's where we will focus on. So discrete events that I just mentioned, that is happening, and you want to react with logic. And the good thing is that you will learn that you can separate someone that is publishing an event, you can separate his concerns from the people or the applications that want to handle these events. And that's an interesting concept to get scale and to move your applications further down. If the session of Eldert gives you good insights, you can even get more insights by reading this blog post from Clemens Vasters, who is like the messaging guy at Microsoft. It's something from 2 years plus ago, but it's still relevant. It talks about when to choose which messaging service for your data. So that's the positioning of everything, where Event Grid is really focused for the discrete events, you could say. All right? Now, I have 3 different common scenarios where Event Grid is being used. The first one would be, of course, serverless. You will hear that quite a lot. Serverless applications where you have the business logic that gets event-driven. So think about, and I'll show that demo, an image that gets uploaded on a website. That's an event that happens on blob storage, and you want to react against that. Without having to write or deploy containers or things like that, you want to just have some logic, very cheap. You don't want to do polling. That's really where it fits. Because one thing is important. if you think back about the days before Event Grid, we were quite commonly using queues or service bus topic subscriptions. And what we had to do, we had to write logic that was constantly polling. So that was a compute instance, quite common, that was polling on these queues. And if you have 20 messages per month, you were still having 24/7 things running and polling. And that costs quite a bit just to handle these 20 messages per month. Of course, with functions and their bindings, I think we have a talk about functions after this and also by Alan tomorrow. But with their bindings, of course, it got much cheaper because you don't have to spin up a virtual machine to do the polling. But with Event Grid, you just have this thing happen. It fires an event and it calls something to you, so you get these events get pushed to you rather than you have to pay for yourself to do all the polling. And that's a big difference in the serverless world. What it also is quite commonly used for is for automation of operations of DevOps scenarios. So if someone creates a virtual machine, if a new resource group gets created, things that happen in the Azure resource environment, you can subscribe to these events and you can have things running. Think about notebooks for automations and so on, where you can maybe have policies that you check, like the virtual machine that gets created. Do I have the right size for that? Do I need to notify someone that he at least can check with the person that created that virtual machine if it's okay and so on? So think about billing and inventory management. And then the other one is application integration. So people that have been using Logic Apps or even BizTalk past in the days, there you can really have communication between different systems where Event Grid is also helping to push things from one application to the other. Again, it's one-to-many, you will see that. So you can have one event handled by multiple receivers. But we'll talk about that soon. One thing I also want to mention is that we believe that open source is really something that, instead of just doing talks, we also want to give back to community code and resources to use. So for that we have Arcus Azure. It's an open source thing on GitHub. You can download the NuGet packages. And I would say Tom is probably one of the most, Tom Kerkhoven, who will present 2 times this conference. He's really adding a lot of code together with Steen at our company. And for Event Grid specifically, we have also one library. So I'll talk about that afterwards a little bit. So feel free to use it. Feel free to contribute to it as well. So we can really help this evolve with the community. Now, Azure Event Grid, that's really the service that, that I'll talk about. And concepts you have is, on the left side, you have the event sources. On the right side, you have handlers. The good thing is that this is the first conference where I was not able to fit all the sources in that left side column, because that's one of the biggest challenges for this service. Event Grid really depends on other Azure services and the other teams at Microsoft to publish and create events. So blob storage, for example, I'll show an example afterwards. But with blob storage, you can just say, if a new container gets created, I want to have an event and I want to do something with it. Same thing with resource groups and Azure subscriptions, as I mentioned, for your automation. IoT Hub is an interesting one. We have some sessions on IoT later on, where you can subscribe to a device that connects and also a device that disconnects. Because maybe you want to know that if a device disconnects, I need to notify someone. So these events get also pushed. Azure Maps is something that is interesting. Also SignalR. So people that use SignalR for front-end applications can really leverage that one. And custom events is definitely a section I'll talk about afterwards. What has been added recently is Azure Key Vault and Azure Machine Learning. So if you have Azure Machine Learning for your models that get published and so on, all these things get automatically fired as an event. So you don't have to do anything for that except for configuring things. You can say, I want to configure on my blob storage account that these and these events happen. And then it's up to you to use something on the right side to handle these events. And you can say, I have some code in functions that are just listening to these events, and as soon as an event happens, I'll handle it. At the same time, if you want to do more workflow, you can do Logic Apps. I think Rick has a session tomorrow on Logic Apps, where you have different connectors and bindings. Think about FTP protocols and so on. Well, Event Grid is a very interesting one because you can just have a workflow started if, for example, my machine learning model has been published. You can also forward from Event Grid to other queues, like event hubs and so on. And you can have on-site things through hybrid connections and so on. So this is getting quite powerful, but still there's a lot of things that are missing, but I'll talk about that later on. So how do you typically configure it? Well, in your event publishers, in the portal, you can dive in and you can select, I want to have these and these events published. So that's an important aspect. Event Grid as such, it's like a sub-service. So you see Event Grid in all these major services like storage, like IoT Hub, and they have a section, events, and there you can configure it, okay? So on an event subscription, you can set different things, and I'll talk about that soon. So this is where I said things that I'm missing. And actually, if you see the link at the bottom, there's another MVP. I think he was here last year, Sean Feldman from Canada, who has set up a GitHub repository where you can create issues. If you feel that there's some event that you would love a Microsoft product team to build, you can create it there. Because the power of Event Grid really depends on that one. So what I'm missing in the types of scenarios, because I mostly work with IoT and data projects, is in Azure Databricks, in the structured streaming, but I'll talk about that later. Azure Functions can listen on events, but cannot spit out events in the bindings. IoT Hub is now being covered, so that's an old one. So IoT telemetry events, if you have that coming in, you can handle them. Stream Analytics, I'll show that. In Stream Analytics, you can output to functions and so on, but you cannot output to Event Grid, which is something I miss. Also in Azure Monitor, there's things missing, and of course with Cosmos DB. Okay, so of course use that GitHub thing because we really want to leverage it towards Microsoft also to put a little bit of pressure from a community and customers. So 5 concepts are important to understand, and they are quite easy if you're familiar with events as a whole. So events is what has happened with a declaration of things inside. You have the publisher, which is spitting out these events. He's raising that. So that publisher can be something, a standard Microsoft service, or your own application. And I'll show that afterwards. The topics, so a topic is where an event gets published to. So the only thing that you have to do if you publish an event is know where to send it to the topic. You don't have to know what will happen with the event. You don't have to care if someone will handle that event. It's perfectly fine to spit out events and no one is listening to that. It just costs a little bit, but at least you're flexible for the future, right? So topics is the only thing that you have to know as a publisher. At the same time, if you subscribe, as a subscriber, the only thing that you have to know is the topic. You don't have to know the source application. So that's the decoupling happens over that topic. So in subscription is where you receive and how do you handle these events. And then we have, Event Grid is really a very powerful service. If you would have to build this yourself, good luck with that. So Microsoft luckily did it for us. So it's an always available service with almost real-time delivery. What is important is that it has at least once delivery. So again, think about handling duplicate messages, right? It can happen that the same event gets delivered twice. And it's platform agnostic. So you can handle events that are being spit out from Azure. You can handle them on-prem. You can handle them in your Amazon, whatever platform you have. At the other side, you can also use other applications and publish events into Azure. So it's really the only thing that you have to be able to speak is HTTP REST, which is, of course, quite commonly known. Also important, there's a maximum size, message size of 64K, which should be more than enough, in my opinion. The way to handle events quite commonly is, okay, inject as much as possible and relevant information, but don't use it as a file or as a message transformation protocol, because again, it could cost. However, there's a message size up to 1 megabyte. I believe it's still in production. and that means it's in preview, and that means it's not backed by SLA. So if you now send messages up till 64, you're backed by the SLA. If you go above that threshold, you're in the preview mode. Okay. This is how an event looks like. I'll not talk about the details. So this is a standard schema with a topic where you send it to, the subject. So that could typically be the device ID of your IoT hub. This could be your machine learning model link and so on. It's an event type. So in this case, this is a blob created. So you can use that to handle it. It's a blob created. You can have a blob deleted, a directory created, and so on. Every event has a unique ID and an event time. When did the event happen? And then you have the payload, the actual data, and that's an open structure that people can use to inject their data. So the data contract for this blob event will be different from the one that you have for a telemetry event of IoT Hub. So that's where you have the flexibility. And also if you publish your own events, this is also what you can use. This is a Microsoft proprietary schema. You can use cloud events at the same time. So cloud events is an open standard that is being adopted by multiple companies. So this is also supported, and you can actually indicate the type of event that you want to receive. Is it cloud events versus Event Grid specific? And I would, if you start with a new application, I would say, why not go with cloud events, because you're even more cross-platform. And the structure itself is quite similar. So the data is where the actual body is, and then you have all these other metadata properties. Performance-wise, this is huge. 10,000 events per second per region, 10 million, sorry. 100 million subscriptions per region, and they aim for a 50 milliseconds publisher latency. So I think that's quite huge. What is important is also that they have failover, because they are pushing to you. And imagine that you have something that is spitting out a lot of events. As the event handler, you have to make sure that you can handle these events coming in, because if you, for example, have an HTTP webhook that you expose that gets called by Event Grid, you have to make sure that that application, that logic, is capable to handle that. And what is also important is that they have retries. So if something fails at your application, there's a new wave coming, right? And they, of course, have some logic internally to not say, if there's 1,000 failing now, we will have all the 1,000 fired at the exact same time. They play and fiddle a little bit with that, but it's still, there's another wave coming, right? So they have also a backup interval. So I think it's 10 seconds, 30 seconds, up to 1 hour. And they retry for 24 hours, right? I'll talk about that in this slide, because it also means, and look at this is cheap. 60 cents for 1 million operations. So if you have 10 million events, it will cost you $6. An operation is, of course, these events, these matches and delivery attempts and so on, and you get 100,000 free operations per month. What is important, and I laid out two things, is first of all, it's per chunk of 64. So if you use that, those messages of 1 megabyte, it means if you have a 640 K, you will pay 10 messages, right? And that's why I believe if you're not sure that all these events that you publish, that they will be handled by someone, I believe it's better to publish something that has a reference to the actual bigger file so that people can go and fetch it afterwards if they handle it. It will be cheaper to do so, and also regarding performance, I think it's better. Another one is the delivery attempts. They also cost. So I just showed the backoff interval. So you can easily have for one message and your webhook is down, or you have even deleted it, but you forgot to remove your Event Grid subscription, and you have that on an Azure blob storage where all the telemetry is coming in. All of that gets retried and so on, and you pay every single attempt. So this is something you have to be carefully monitoring, right? Now, I think I talked about publishing events, how Microsoft Azure and their services are publishing events. Of course, what you want to do now is do something with these events. You want to write logic, you want to have your processes being kicked off, and that's by consuming these events. So the first one I'll talk about is webhooks. So webhook is Very simple. It's an HTTP endpoint that gets called with a payload. It's typically a post. And what is important is you cannot have every web endpoint listed there. There has to be a validation. Think about a website from your competitor that has a big announcement, for example, and you say, oh, I want to have something denial of service attacked. What you could do, oh, I will list that website as a subscriber to events, and I'll just have something writing all these blob storage things, so that Azure Event Grid is pushing and hammering it. Azure Event Grid will be much more powerful than most of the regular websites, for example. So you cannot just do that. The only thing that you can do for a webhook to subscribe is to have a validation handshake, and I'll talk about that. What is also important, and I feel that there's something missing, is that it's quite limited in security. So the way to secure your webhook is only by passing in something through a query string, like question mark key equals secret key. So you cannot have a secret key in a header or something configured. That's something that I'm missing, and of course OAuth is definitely not in place there. So how does the validation work? If you create, the first time you create and start up an event subscription for a webhook, you will get this message, which is in the event type. It says subscription validation event. And that subscription validation event gets a key. That key, in this case, starts with 512, the validation code. And you can just, you have to send back the validation response with that key. So that's the handshake that you have to do. If that happens, as from that moment, they will start sending these events to your webhook. Okay? So the way I will demonstrate this is with request bin. People use and know request bin, I hope. If not, this is a free tip. So with request bin, you can create a request bin. I will not do the private because then you have to log in. And this is now just an endpoint. Of course, people can now start sending to this. Let's not do that. But this web endpoint is something that I will use, and that you can just start spitting events, and you can really monitor what happens. So it's like an inspector in the cloud. So what I will do here is now I will set up in my portal a very basic event handler that just sends all these messages to the cloud. And I will do that with blob storage, because it's very easy to demonstrate. So I have somewhere, let's mute. Here I have a storage account. And as you can see, and I'll zoom in the storage account, this is where Event Grid is hosted, in events. That's where I can have my events configured. So it's not that I have to go to Event Grid as a separate tab. Event Grid is embedded in all these services that support it. So with the events, what I can do, in the portal I can very easily say I will create a new event subscription. So I just give it a name. Let's call it Igloo Demo. Here you specify the type of event. So you want to have your cloud event, the open standard, or you want to have the Event Grid schema. Let's pick the cloud event. You can also use your custom schema. If you really want to do that, and if maybe the receiving application is something that you cannot control or change, that's how you can fiddle with the request that you will send. So here it links with the storage account, and this is where I can specify the type of events I will enable. So by default, I have every blob that gets created, every blob that gets deleted, and these are more the data lake events, like directories and blob renamed and so on. That's specific for data lake. So I will have these events listed, and then I have to specify these endpoint details, where I specify, and let's zoom in again, you have an Azure function. So that's the session of Martin and Alan. You have a webhook, which I will show now. You have storage queues, which I don't believe you should use. You have event hubs. Hybrid connections is to send to something on-prem. So you can have an endpoint in your own data center or on your own device that is actually registered in the cloud, and that's how you would call into that without opening and drilling holes in the firewall. And then you have service bus queues and topics. I think Eldert will talk about those. So let's pick webhooks in this case, and I have to just specify the endpoint. So that's where I will copy the ID from there, or the endpoint, and that's also where I would pass in my secret key with a question mark, with the query string. So as soon as I click create, which I do now, there should be, if internet goes well, there should be something pushed here, and that's that validation handshake that I talked about. And it's still waiting for the first request. And that's, of course, what you don't want to see happening. So it needs to be validated before the subscription is created. That's at least what it shows. Let's do an F5. Let's forget about that one then. This was the most simple demo you could imagine. So what happens is Microsoft would now push that message into this endpoint, and I would get, if I go back to the slides, I would get the validation URL, which is an HTTPS endpoint, and the only thing I have to do is I have to do a GET, and actually I pass that validation code in that GET, and as soon as that happens, the handshake is done and created. So this is probably just taking a while. Let's forget about the validation here. What I also want to show is how can you do filtering. Because of course, as soon as you send out events as an application or as Microsoft, you get a lot of events with metadata information. What you want to do as an application, as a receiving application, is probably you want to do some filtering. Maybe you get events for all the blobs in that storage account, while you might be only interested in the ones that are coming from that specific container. Or you're interested in all the events coming from that specific IoT device. So what you can do is you can have subject filtering. So if you think back about how the schema was looking like, it always contained a subject, and the subject refers to the actual originating publisher. Like in this case, you would get the file name, the blob file name. And you could say, oh, the subject has to end with, in this case, for example, .jpeg. And you would have a handler that only handles the JPEGs. Maybe you have another one to do image transformation on the PNGs and so on. You can also say, oh, I want to have the subject filter to do start with, because there you have the container, for example. So that's how you can do very simple subject filtering. What they have added is advanced filtering. So with advanced filters, you can have much more filters that are looking into the data. So if you have in the data payload structure, you have data that you want to use to subscribe to, that's where you do it, just by using the dot notation, so JSON structure following. That's how you can specify very easily filters that say, okay, this is, for example, data.message.type. And here I can specify equals string in and so on. So this is like a very simple rules engine if you want. So that's the advanced filtering that you can do. And then you have the additional filters, messages that, or features that I talked about, that are more around how to handle the retries and so on. So the dead lettering is something that you might be familiar with if you come from storage and queuing and things like that. So what you can do, I can say if the delivery attempts have failed and have been exhausted, I still want to have that event saved, and that's what you do here. And the only way to save it is by storing it into a storage subscription. Of course, you can, on that storage subscription, again have event handlers and nicely propagate things. Then you have the retry policies, as I said. So this is standard policy that I explained. You can fiddle with that. You can say an event has a time to live, like the event after the time to live, it will be dead lettered. And then you have the subscription expiration, which is, like for demo purposes, quite easy to do, where you say, okay, I make sure that the subscription deletes. But at the same time, I can see scenarios, again in serverless applications, where you created an event handler, and you say, oh, this event handler is only, I want to monitor something for a flight, for example. I will have this event handler automatically expire after the flight has taken off, for example, right? That's the way that you can play with that. And you can also do batching and AAD authentication, which is a new one that I didn't look into. Okay? So that's a basic overview of how to create event subscriptions. And let's forget about this one. So that's the validation. So I talked about filtering in two ways. So this is on the right side, and it's probably not well readable, but the advanced filters, they are also part of the ARM templates that you want to deploy, and that's the structure they have. So you have an operator type, a key, and a value. Exception handling, as I mentioned. And as the demo that I have to just show a very simple lightweight application, I have a Finnish menu translation. So let's go to the thing first. It's a talk like a Dutch day, but I don't know how I have to pronounce this. I can only imagine that it's a lot, because it's a long name, so I would have a lot to eat. So this is, of course, the Finnish menu that I don't know what I would order, except for number 5.
It's 1 meal.
It's 1 meal. Thanks for that. It's a salad. So what I have is I have actually 3 storage containers, just for demo purposes. I would not build a real live application like this, just to get the gist. So if I upload this menu into the menu input, what happens? I have Event Grid that registers to the event, the blob created. And then I have a handler, which is just a webhook. So it's an API that does that validation handshake, and then says, I will use, on the right side, you see cognitive services to do the OCR. So OCR is character recognition from the image. And the output of the OCR would be text, still the Finnish text. And it stores the Finnish text into the menu OCR. And there again, I have a blob trigger that goes to the event grid. And again, I have a different subscription using the filters to say, oh, if it's in that directory, I want to have the other operation called in my API. And that is just calling another cognitive service, which does the translation. So it translates, I believe, into English. And then the stored menu, the translated menu, will be stored in the other directory. So that's how it goes in this setup. You have at the bottom the 2 subscriptions that you can see, but let's show it live at work. So we have the storage container here, so menu input. So I will upload the file. Finish menu. And the only thing I have to do is upload, and all the rest happens now automatically. So let's do a refresh on the OCR. And you can see that there's a new message received at 44. And then we have the translated output, where I do the refresh, and now we can see, if I download this one, maybe I can just open it in storage. You can see how well the translation goes. It's not perfect, definitely, but I might go for the cold smoked herring caviar, which is quite okay, I guess. So that's the way things work. Let's go back to the actual events in the portal now. So if I go to the storage overview, as you can see, I have all these events at the bottom, right? For demo purposes and so on. What is the one that I want to show here? It's these 3, the event, menu new, menu create, and so on. So on the OCR, you can see very simple, how many events get handled. What happened, I think the last time I executed this was when I was, I think it was in Belgium, doing this talk, and I didn't touch it, and it still just works, and I pay peanuts, nothing for this, because it's all serverless, and it only happens whenever I drop that file. So I don't have to pay for Event Grid just because I use it. I only have to pay it when I would use more than 100,000 menu translations, and I don't see a business case in that yet. And here you can see that I'm calling this API at the bottom. So the storage account with that, and I can then see the filters. And here I have used the subject filters. Subject begins with this, and here I'm pointing to that specific directory. All right? Going to the code very quickly. This is where I have that translator happening. So it's the API controller, very normal, and it's 2 years old. I think not even in .NET Core. But I had created this specific subscription validator that does all the handshake validations. All of that is available in Arcus. So for that, let's go here. So this is the Arcus GitHub that you can just get access to. If you click on Event Grid, then security, I guess. You should be able to see here the Event Grid subscription validator. So we moved everything away from that ugly code that I write, and then we have people that do much more decent code, and that's a result of this. So what they did, they actually created an action filter attribute that they hook into the HTTP pipeline. And then we say, okay, if the action context contains the AEG, so all the headers that Azure Event Grid is sending start with AEG, Azure Event Grid. So if the event type equals subscription validation, then what I will do, I will handle the subscription validation event. And that's what happens here. So I'm reading the event and so on. I do some basic validation checks. And if I get the validation code, what I do is I return a new message with the status OK, and that contains that validation code thing. So this is all done for you. The only thing that you have to do is use this attribute on your HTTP controller, on your API controller. You tag it with this attribute, and everything happens for you. So you don't have to care about that. It's just adding this with the NuGet package, and all goes automatically. All right? Now, we talked about how to handle things, and you can do it with logic apps and so on. I'll talk about that soon. You can also publish events. And to publish events from your own application, the only thing that you have to know again is where is the topic. So you have to know a topic endpoint, and of course, you have to know a secret key, an authorization code. So you create a topic in the portal, and then you can copy the authorization keys from the access keys. Again, on a topic, you can see perfectly how many events have been published and how many events have been handled with Azure monitoring and so on. So you can subscribe to that. You can really use that also as metrics for you. So to publish topics, you have, of course, the SaaS key and the SaaS token possibilities for authentication. And what is also being added is event domains, and that's a special one. So think about an enterprise that has events to publish, but actually it wants to know that I'm publishing events from my application, but this specific event should only be accessible by my customer A, and the other one should only be accessible by customer B. So you want to have some security, but you don't want to create a specific topic for all the different, a specific publishing topic for all your tenants. What you can do here is you can use Event Grid domains. So from a publishing point of view, you publish to Event Grid domain. The only thing, and that's what I don't like here, the only thing you have to do is you have to specify to which topic at the receiving side it will happen. Because if you look at the right side, maybe I should zoom in again. So you publish to this domain-specific endpoint, and as from there, because I have specified in my publishing event that it has to end up at topic 5, for example, it will be routed to the Redmond construction in this case. What I would love to see, though, is that I can just have it published to an event grid domain, and that I can specify the routing logic on the domain that, again, as a publisher, I don't want to know where the message has to end to. And that's what I don't like. So what I would hope is that I can do routing inside the domain by creating the rules there. Or another option could be if you could have an event grid topic subscribing to another topic, so that you have something like a forward to. And if you have another event grid topic that is actually being capable to handle events, you can have one incoming event on your publishing topic that gets distributed to multiple other events, and you could have other people registering on all of their own topics. I would love to see that, rather than this approach where, as a publisher, you have to specify it has to end up to that topic, because I cannot do one-to-many. Okay? But still, it's a nice approach. What is also interesting is that on the receiving side, on the subscription side, so your customers, if you want, your tenants, they can subscribe to this topic, and they can use Azure Active Directory of their own tenant. So they can use that as authentication mechanism to get access. So this is more intended for enterprise scenarios, but I hope that is coming. What you also have is domain scope subscriptions. And again, you have to get access to that. But you can say, I want to have a subscription on all these events, regardless of which topic they will go into. It's like for auditing purposes or for your own application internal logic. Okay? Now, DR is definitely something that is crucial in this setup. So they have different things for metadata versus the actual data. What is important is that all the information of the health endpoints, and that's what you want to use if you want to do manual DR and manual actions. All that information is available on an HTTP endpoint API.health on your topic. So you can use that into your logic to do failovering, to do scaling and things like that. All right? What I also wanted to show is how you can use Event Grid in your integration testing scenarios. And again, I'm using shamelessly the content from Tom here, who created the blog post of that. But what he did is he actually creates a topic, an Event Grid topic, and if you want to see how these publishing of events happen, you want to have that back in your test. So in your test, you can say, I submit an event, and I want to have something subscribing to that event and do my validation check there, like you're testing your asserts. And that's what happens here. So behind the scenes, and you can just deploy a template for that, behind the scenes, we're from that topic having a subscriber that is a function, and that puts it on a queue, so a service bus queue, and your test will create a subscription. So at the start of the test, it will automatically create a subscription on the topic. And again, session of Eldert will give more details on that, I think, on topics and subscriptions, to say, I want to listen to all the messages that come from my test. And you have that subscription created. It pulls the event. As soon as the validation happens, it also creates, or deletes, the subscription. So the topic itself remains clear. And that's how you can quite easily do real integration testing, rather than stubbing everything out with pure unit tests. Okay? Now, the other one that has been added, and this will definitely link to the session of Martin tomorrow, because he doesn't speak Dutch, is Azure IoT Edge. So Azure IoT Edge is the service that you can run in the field for your IoT solutions, and it comes with different modules. So the modules that you have are actually containers, and Martin will talk and show all of that, also how you can create your custom modules. But these modules, they run locally, so you can build your custom module to read the output from this projector, for example. At the same time, you can use modules from Microsoft. So Microsoft, for example, has Stream Analytics that you can run in the cloud, but you can also create Stream Analytics jobs that you execute on the edge, so close to your devices, for example. Also blob storage. You can have a blob storage in the cloud, but you have a blob storage service on the edge. So all these things ship as containers to your edge device. Now, what is important is that for Azure Event Grid itself, they also have created a container, and that container can be running on your local device. Now, this allows you, for IoT Edge, to have Event Grid working as a publisher and as a receiver on the edge. And one thing that I have some problems with is, okay, when to use Azure Event Grid on the edge to do the routing between all these modules versus when would I use the standard routing mechanisms that Martin will definitely talk about. Because the standard routing between one module and another module on IoT Edge, they go over that, let's call it the local storage, but it's the Edge hub. It's like a mini IoT hub on your device, and it's more asynchronous queuing, where with Event Grid, you can do push from one module to the other, okay? The difference that I see for scenarios, and when I can use it, is if you want to do device-to-device communication. Because you can have Event Grid on 2 devices, and you can communicate to each other. You can subscribe to events from another device. Think about one device that handles something in the production line at the beginning, and it wants to send an event like, whoa, I think I have some bad quality created, so maybe you want to handle that and you want to know it further down. That could be a way to notify each other. Because, that's the nice thing, Event Grid on the edge, it's really symmetric, so if you want to use it and if you want to send events and publish events on the edge, you just use the same logic, the same DLLs, the same HTTP endpoints and so on. But you can have a mix between module-to-module communication, and that's where I still would use the IoT Edge standard logic. You can use edge device to edge device, and you can also use it to do cloud to edge device. So you can subscribe with your local IoT Edge device on events that happen in the cloud again, using the same patterns. And you can use your Edge device to publish events into a topic that is in the cloud as well. So this makes it all quite complex for your IoT scenarios. But what I also see is that since they have now Azure Event Grid in a container, in a Docker container, and they deliver it still in preview, by the way, they deliver it on IoT Edge. What I see is that the fact that they have it in a container, I see and I hope that they will also ship it regardless of IoT Edge, that you can just use Event Grid like they did with API management recently with Arc. So you can use API management locally if you can have Event Grid locally. And I think the vision of the engineering teams of Logic Apps was also, I think 2 years ago on Integrate, they said, we also want to have that running everywhere. So if that is also coming, you could see scenarios where you have things on-prem that are still relevant today for mission-critical production scenarios. You can have the same services running there that then integrate into the cloud and back and forth without having to fall back on legacy software to do these type of things. So the good thing is that if that motion continues, and this will still take, I think, year plus, but if that motion continues and is successful, at least you can develop one distributed application once, and ideally you can execute it everywhere, in your own data center, in the Azure data center, and maybe even cross-cloud, okay? So that's the thing that I wanted to share with you on Azure Event Grid, specific to the edge. Specific to the edge, you have different sources. So as I said, you have the blob, Azure Blob on edge. You can subscribe to that. You can have, again, your cloud events and your custom events, right? So you can have custom modules that subscribe to these things. Now, specific on the final demo that I want to give, I took a real-time analytics scenario for traffic cameras. So you might have that in Finland, but speeding cameras, I think we are familiar with that. What used to happen is they measure the speed at a certain point in time. So the velocity of a car that passes here. So the result of that, people start to know Waze is alerting that there's a camera in 500 meters. So people are driving at 150 where they can do 120. 100 meters before, they brake. 100 meters after the camera, they take off again, right? The only result was that people were causing more danger to other people with doing strange incidents. So what they do now more and more is to have segments on the road with traffic cameras at the entrance and at the end. I don't know how Finland is, but this is really coming popular in Belgium, unfortunately sometimes. But what they do, they actually scan your license plate at the beginning, and they scan your license plate at the end of the segment. And these segments can take 8 kilometers, and that's a long time sometimes. So they scanned things, but of course, in that segment, as you can see, you have cars that speed faster than the others, so it's not that, it's a sequential thing. This is a typical scenario for streaming processing. So what they do, they scan the plate beginning and end, and then they take the difference of time. When did you pass here, when did you pass there? And that difference cannot be less than the maximum driving speed. That's as simple as that. This is a common scenario for event detection, because there might be thousands of cars coming. Hopefully, there's only a few that speed. Hopefully, depends on if you want to look at it from a safety point of view. Maybe you want to hope that there's a lot of speeding if you look at it from a budget point of view from the government. That's another thing. So what happens is that as soon as the car gets scanned at the left side, an event is being, it's not an event, this is like the time series events, right? This is a stream of events. This is not Event Grid that I'm using for that one. So I'm using IoT Hub as a telemetry stream to capture all these camera events. So the only thing I know is in which lane was it driving, what type of car was it, the license plate, of course, the make, is it a BMW versus a Jaguar, the color, and so on. And I have that at the other side. So all of that gets into IoT Hub, and that's where I want to detect which cars are speeding, okay? And that's what I do with this architecture. So, and I'm not diving into the details of this one, that's another talk, but on the, so all the data gets sent from IoT Edge into IoT Hub, and on IoT Hub I have two streaming things, just for demo purposes. I have Stream Analytics, that is a SQL type of query that is a standing query and listens on that IoT stream, where it does slicing windows and checks, okay, do I have this happening? So as soon as a speeding car gets detected, it wants to publish an event from that query. The bottom one, the red one, is Databricks. So Azure Databricks is for machine learning, is for structured streaming, which I used in this case, to do data-specific things on cross-platform scenarios. So there I also have a query that is running. It's like a notebook, if you want. And I want to detect suspected cars. So in this case, a suspected car could be someone that is flagged at Interpol, like that car has been stolen and so on. So I want to know that if something happens by one of these cars, I also want to notify. To do that, I'm using Event Grid at the receiving side. So on the left side, I use IoT Hub, which is backed by an Event Hub, if you want, on the messaging scenarios. But on the right side, I just want to throw events from my data structure. So I detect these things, I throw an event, I emit it, and from the data pipeline, I don't want to know, I don't want to care what happens with the event. I just publish it. I don't want to know if they will automatically send a fine or they automatically publish it on a dashboard, whatever. This is a perfect isolation I want to have, and that's the loose coupling. So I publish the event from Databricks to an Event Grid, and I have the same thing from Stream Analytics. If you think back about the missing publishers that I talked about, I was hoping to do an automatic output from Stream Analytics to Event Grid, because that's a perfect scenario. You listen in an event stream, maybe it could be log files from a website, I see suspicious behavior, I have a machine learning model that detects things, I just want to output that as an event. The reason that I have a function there is just because there's no standard output to Event Grid. So I had to output to a function, and then the only thing that the function does is using the Arcus library to publish it to the topic. So I hope to see that bypassed. Okay? So if I go to the actual scenario, here's the portal. So I have, and that's also interesting for you to know, if you want to play with this scenario, because it opens for a lot of other types of things if you want to do stream analytics and so on. I also made that open source. So here on my my own GitHub, I have this project where you can just download these things. There's also a container published on, I think, Docker Hub that you can just use. I think let's go here to the README. You can just use and deploy that container on your own, whatever preferred scenario. Here, the public camera simulator. So it just creates a stream of license plates that get created with a little bit of speeding and so on, and you can configure things. So an example is so these events that get configured, and you can start. It's fully explained how to run it, how to store it as an edge module or as a standalone module. The good thing is that it splits these events into IoT Hub. So if you want to play with IoT Hub and you want to have some real-life-like scenario with data, that's something you can use for free. So just do the Docker run here of this container for you to use. Now, so that container is running, it's splitting these events in IoT Hub. And then I have this stream analytics. There's too much resources at a certain point in time. And yes, I know naming conventions. So this is stream analytics for people that have not seen it before. So I have a query here that looks very SQL-like. Let's do it in full screen. So this query is just detecting, in this case, I'm joining with segment configuration and so on, which is coming from Blob. But the most important thing is I do a group by, and I group by the traject, so the segment, the camera distance, and so on, and I do that by a sliding window. So I keep 20 minutes of things in memory in stream analytics, and if I see 2 cars, because it's grouped by the license plate. So if I see 2 events from the same car with a date difference that is, I think here I do that, with a date difference that is smaller than the allowed amount, then I will output, in this case, to speeding events. And as you can see, this is a function. So that's where I was hoping to get Event Grid as an output. So this function is very straightforward. Traffic demo. It's an Event Grid trigger that runs in, or it's a function that runs as with an HTTP trigger here. I called it Event Grid trigger, and the only thing it does is taking the request body, adding it as an event. Let's zoom in. Yes, so I'm creating a car speeding event, which is just a typed name for my car speeding. I give specific things here, which is the subject ID. So the subject, like the blob container and so on. If you publish your own event, that's how you have to think about how do I structure my things, because the subscribing applications want to register and want to filter on that. And I want to send the car speeding data. So that's my payload. The only thing I do here is I publish these events with the Arcus client to the topic, and that's done. So this is something that I was hoping to emit. At the other side, I have my data bricks running. It should be, it's here. So data bricks, and let's not go in these details, but this is a Python notebook that just runs and listens on all these incoming data streams. It again checks for suspicious cars. And if something of these things happen, what I did, and I hope I still have it here, yes, also open source, is an Event Grid sync writer. So this is something in Python for people that want to use it. But if you use Databricks with Python, you can publish and you can say, I want to write to a stream, to a sync is what they call it there. And this is just the Event Grid stream writer that is using these Azure.Event Grid. So this is the SDK from Microsoft that goes for Python. So the good thing is Microsoft is totally cross-platform with these things. So you just run it on Python. And there, what I do is just publish these events. So you specify, the same things. And the only thing that you have to do is publish these events with the topic URL. And that's how things go. Okay? So that's what I do from this notebook. Again, all of that code is available on that GitHub if you want to play with real-time data streaming and so on. Okay? Going back to the portal, I also have my logic app there that says I want to create a speeding ticket. As you can see, 5 minutes ago there was a car speeding apparently because I have this logic app that kicked off. If I first show how the logic app gets created, so again, Rick will dive into details tomorrow, but you have connectors and triggers. And this is, in this case, the Event Grid trigger that I can zoom in again, where I specify how do I handle these events coming from my custom application. Well, here I say the resource type is, in this case, not IoT Hub, it's not Blob, it's not storage or machine learning. In this case, it's Event Grid topic. That means this is for my custom events that get published. Then I specify the resource name, so which topic. And here I say, what type of event do I want to subscribe to? In this case, I want to subscribe to the speeding car detected event. I give it a name because every subscription has a name. And then the only thing that I did in this case was just to show how I can access the event data. The only thing I did was check how to get the license plate from that body. And this is with the perfect, nice language of logic apps that Rick will dive into, because I'm not sure I want to do that today. But I just get the license plate from the data payload here. Okay? And if you go back to the results, or to the history, here you can see a replay of one specific instance. You can see that this was license plate 1RX and so on. And here I can do whatever logic I want. I want to create PDFs. I want to send something to another, like the police or whatever, to handle these things. That's all fine. But all of that logic is perfectly decoupled and can be done by a different team than my data science and my data streaming team. And that's something that I really believe is helping the scenarios to be built in a way that we are scalable enough. I hope that the overview was interesting. I hope that you've seen that Event Grid is really in the middle of Azure, of the ecosystem of the services. Only the fact that I think I touched almost all of the sessions that will come later today a little bit with Event Grid is important. So it really allows to build applications at scale. What I think is something that I can give as a takeaway is that you can leverage the out-of-the-box events from Azure. So Microsoft is adding these things, these publishers automatically. So if you're inventive and you just say, I use these events and handle something, it's really powerful. What I also want to do is make sure that you think about, if you build your solution or your application, think about relevant events that you might want to open up for other applications. I think a success today in building cloud-based applications and platforms is really if you can open up for integration and extensibility towards the other world. If you do that with on your own, that's fine. But a nice way to do it is just by opening it up, by publishing all these events to a topic, and then you can have other people subscribing to that. I think it's quite powerful. And the best way to do, and that's something that I've been doing because I started with BizTalk, I said it again, but the best thing you can do is think decoupled in these scenarios. Decoupling is really helping you to scale things and to have a separation or segregation of responsibility. And the last takeaway, please guys, enjoy the conference because I think it's an awesome one. Thank you.